and I just think it'd be just fun to go to another planet.
Set up like cities out in space.
I think I want to go on an Apollo mission so I can do a spacewalk.
Since the early 1960s, when the possibility of human space travel became reality, kids, and adventurers of all ages, have dreamed of going into space themselves.
Sometime in the 21st century, your children's children may very well fly Pan Am to the moon.
In 1968, Pan Am kicked off a curious ad campaign. They were accepting reservations to guarantee seats on their future flights to the moon. 93,000 people made reservations.
I was one of the first 100 to make a reservation for the moon flight. I was working at the William Morris Agency at the time, and a very excited Albert Brooks, who was one of our clients at William Morris, came running into my office and saying that he just heard that Pan American Airways is taking reservations to the moon.
They were taking reservations if you wanted to go to the moon. They were eventually going to have a ship that would go there. I sent away for tickets for me and my future wife. I didn't even think about maybe I'd have kids.
Affairs are not fully resolved and may be out of this world. We ask you to be patient. Is 28 years enough time to be patient?
There is no environment more alien to the human body than the emptiness of space, where temperatures can fluctuate 500 degrees, where, without the protection of a spaceship or a spacesuit, the vacuum would make blood boil. It takes the most sophisticated machines ever built to get into space, and the effects of long-term space travel on the human body are still being studied. So why do so many people want to go?
This whole idea of how somehow, through our exploration of what's out there, we could come in contact with our relationship to the divine is, I think, a big part of why we do this.
I think one of the real reasons for exploring space is to see if we're alone in the universe or whether there are other life forms out there. It's hard to think of a more important question from the point of view of philosophy, religion, sheer curiosity.
That's one of the main driving forces of my interest. I want to find the aliens too.
You got company.
Whether searching for aliens or even God, a basic reason for exploring space is simply because it's there.
We're fascinated by pretty much any open frontier. Think of the effort that went in the first part of this century in getting to the poles. Or why did we keep trying to get to the top of Everest? It was simply a frontier that we hadn't been to. And space is the same thing, which is why I think we have a long future in going to space.
Humans are natural nomads, and we've always somehow been restless and moved around from one place to another for reasons we don't know. I assume that will continue to be true. So there are lots of reasons why people might like to go. The simplest is just to get away from their neighbors, and that's, I think, a fundamental instinct in many of us.
Another good reason for exploring space has only just been discovered. We realize now that the Earth is continually bombarded by asteroids, comets. It doesn't happen very often, but when it does happen, the effect can be devastating. Meanwhile, it would be a pretty good idea to establish a few other colonies on the Moon and Mars and elsewhere, so that even if there's a major catastrophe to the planet Earth, some part of the human race will survive.
6, 5, 4, 3, 2, 1, 0.
The American obsession with space began in 1957 with the news that the Soviet Union, the United States' Cold War foe, had successfully launched a satellite into orbit. The space race was on.
At an altitude of 560 miles, at an estimated speed of 18,000 miles an hour, the first man-made satellite is orbiting through the heavens, sent there yesterday by Soviet Russia.
In 1961, the Soviets stunned the world again when they launched the first human being into space. About his trailblazing single orbit of the Earth, cosmonaut Yuri Gagarin said, "I looked and looked and looked, but I didn't see God." The Soviets may not have found God. They did find glory. A few weeks later, the United States successfully managed to launch astronaut Alan Shepard on a suborbital fleas jump, as the Soviets called it. Shepard's 15-minute flight was technically into space, but just barely.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. We set sail on this new sea because there is new knowledge to be gained.
President Kennedy became determined that the United States would be the first to land an astronaut on the moon.
For the progress of all.
Kennedy didn't live to see his dream fulfilled. When Apollo 11 reached the moon in 1969, American astronauts Neil Armstrong and Buzz Aldrin became the first human beings to step foot on another celestial body.
To realize that you've been blessed to do what very few people can do, you just pinch yourself and say, well, how lucky can I be to have done this? It's the highlight of a life because unless you're going to hide, you can't remove the fact that people are going to look at you differently.
Since those pioneering steps of Aldrin and Armstrong, only 10 other people have been on the moon, and fewer than 400 have journeyed into space.
You got the flag up now, and you can see the stars and stripes on the moon.
Take the biggest roller coaster you've ever ridden and multiply it by about 10.
You have the opportunity for a lot of exciting things.
I don't think it's productive to sit there and think about all the many thousands, millions of things that can go wrong.
Very large sounds, vibration, shaking, motion.
Smoke and fire billowing up around the front windows.
Propellants they use on the space shuttle are very, very potent, and it's like a gigantic controlled explosion that lasts for 8 minutes to get you into orbit. The space shuttle main engines are a very incredible device. They generate enough force to levitate 200 cars, and they could hover them stationary midair. The fuel amount used is tremendous. The turbo pumps that supply fuel to the engines pump enough liquid it could drain a swimming pool in less than 30 seconds.
Space begins at the edge of the Earth's atmosphere, 50 miles straight up. But the shuttle orbits at an altitude of about 180 miles. How does it get up there? Space travel is all based upon Isaac Newton's third law of motion. This fundamental principle of rocket motion is 300 years old, and we've enlisted rocket scientist Wayne Lee to explain it.
Believe it or not, you don't have to be a rocket scientist to understand how a rocket works. This balloon here is essentially a rocket that's powered by compressed air. What happens is that when the air rushes out, it propels the balloon forward up the string. This is exactly Newton's third law at work. When the balloon throws the air overboard, the opposite reaction propels the balloon up the string.
Wayne Lee put on ice skates for the first time in 15 years. All in the name of science.
Newton's third law says that for every action there is an equal and opposite reaction. So simply stated, that says that I cannot push on something without that something pushing back on me with equal strength. And so as in this example here shows you how rockets work. You can imagine that I'm the rocket and my partner here is the rocket fuel. I am pushing off on the rocket fuel and that propels me in the other direction.
Apollo 13. Congratulations, everybody there. Nice evening, and we're just about ready to close out our...
For film director Ron Howard, the most challenging aspect of recreating the drama of the Apollo 13 spaceflight was figuring out how to show weightlessness.
We were doing something that no film company had ever done before, and that was we were actually trying to give the audience an authentic sense of what space travel was like, including the weightlessness.
Astronauts in space look like they're floating, but actually they're falling. For this demonstration, Wayne Lee asked for a stunt double.
Surprisingly enough, weightlessness for an astronaut in space and free fall of a bungee jumper back to Earth is exactly the same. The difference is in the feeling. An astronaut appears to float rather than fall because the walls and floor of the space shuttle is falling with the astronaut in orbit. As a bungee jumper, however, you feel the air rushing past your face and you can see the ground coming up to meet you.
I thought there was a weightless room somehow. I knew that astronauts practiced, and I assumed that there was a place to do it. And I learned that that doesn't exist, but that they can simulate weightlessness in an airplane by doing a parabola, which is sort of like a big roller coaster maneuver in the sky. As you're sort of going over this hump, it sort of tosses you, and then the pilot flies the airplane in an arc that basically flies around you as you are free falling. You really can't wait for the next parabola. I don't know if it's a throwback to some embryonic sort of recollection that we have or what, but it's very soothing and exhilarating and a lot of fun, you know, because I never got to do this because I was always involved in every shot. But anytime one of the actors was not in a scene, they didn't go and rest somewhere. They went to the back of the aircraft, and on every parabola they would play Superman because you felt like you were flying. And there were all kinds of zero-G games going on there with frisbees and footballs and stuff that were a lot of fun. But it's an amazing feeling, and always a little bit of a letdown when you finally land and you're walking across the tarmac, and you know, all the usual rules apply.
When I'm falling on this ride, I feel weightless because I'm falling with the car. I get lifted out of my seat. This is the same feeling that astronauts will experience in the space shuttle. They appear to be floating because they are falling around the Earth with the space shuttle. And it is this falling that gives the illusion of floating.
There's nothing that matches the adventure of weightlessness in space, looking out and contemplating the void with the stars and the beauty, and then looking back on Earth where all the rest of the people are, the unlucky people. You're the lucky one because you're up in orbit.
How do those lucky few stay up in orbit? Back to the skating rink and Isaac Newton's laws of motion.
I chose this place because it's the best place on Earth I could think of to show frictionless motion similar to what you would experience in space.
Newton's first law of motion states that a body at rest tends to remain at rest, and a body in motion tends to remain in motion at a constant speed in a straight line, unless acted upon by an outside force. In other words, the puck doesn't move until the stick hits it, and the puck would slide continuously in a straight line if nothing impeded its progress.
A hockey puck is not going to slide forever because there's friction between the puck and the ice that will eventually slow the puck down. But in space, there really is no friction, so once you set something in motion, it's going to keep going until something stops it. Gravity is an essential component for orbiting the Earth because without gravity, the spacecraft would fly away from the Earth in a straight line. It would never come back. It's the gravity that provides the force to keep it constantly circling the Earth.
And speed keeps a spacecraft from being pulled back to the ground. At a comfortable orbital velocity, like 17,500 miles an hour, the shuttle is going fast enough to fall around the curvature of the Earth. If the spacecraft slows, gravity pulls it down before the shuttle makes it around the curve.
When you're in space, now you are just automatically in that freedom of floating around, and it's a marvelous experience. And you get to look outward, you realize the velocities that you've got as you see the Earth 100, 200 miles beneath you from a perspective that you'd only get before from artists or maps or globes, but now it's there, and you get to see Gibraltar and Spain and the Mediterranean.
Now the spacewalk is fun because you're outside. Your view is not as limited. You can look all around you, see the stars, and if you gaze over the side, you can look down and see the Earth beneath you. But on the other hand, it's a lot of work because the suit is so bulky and it's pressurized, therefore it resists every movement that you're trying to make. If you want to squeeze your hand as if gripping a tool, the suit wants to spring your hand back. If you want to raise your arm and turn the lights on your helmet, the suit is attempting to spring your arm back to its extended position.
During a spacewalk, I am never scared. I am never fearful. It is like a ballet because it is slow, it is quiet, just like the background fans in this room. What you're hearing in this room, this is what you hear during a spacewalk. A nice, soft hum, and that tells you that airflow is coming over your head, that your water pumps are working. And it is so slow, you put things here, and it's this kind of business.
We circle the Earth every 90 minutes, so you've got 45 minutes of night and 45 minutes of day, and then you go through this cycle over and over and over again. You can actually look out and see the terminator between night and day coming towards you. You've got brightness, and you can look out and see the little gray area and then night as it moves toward you. You move from daytime into night in just a matter of seconds. Space away from the sun can be as cold as minus 250 degrees Fahrenheit. In the sun, direct sunlight, it can be as warm as plus 250 degrees Fahrenheit. As you leave the sunlight going into darkness, within a matter of seconds, you can actually feel that temperature change. Your suit has to stabilize the temperature for you.
Although orbiting Earth is the experience of a lifetime for those lucky few who have done it, astronauts have been stuck in Earth's orbit since the last Apollo mission to the Moon in 1972.
The Moon is a very desolate place. I said so when I was there. Magnificent desolation. Magnificent because we got there with our little toy spacecraft, and we pranced around for a while, and that was a magnificent fulfillment, but it's a desolate place.
Now, the Moon, in a sense, we did, and it's not very interesting. It's interesting, perhaps, as a place where we will get resources which we can put into orbit inexpensively and use to go further afield, but it's not a very good destination. It's an offshore island, it's not a new continent.
In 1993, an event occurred that underscored this attitude about the Moon. Been there, done that. Sotheby's auction house held a Russian space auction that some described as a going-out-of-business sale for the post-communist Russian space program.
And $5,000 a bid now, bidding at $5,000, $6,000, $7,000, $8,000.
Halfway through the discussions with the Russians, I asked them if we couldn't have something maybe that was on the Moon or on Venus, you know, when the space probes are on Venus or on Mars. And they did not understand what on earth I was talking about. I mean, it's there. I mean, you can't sell something that's on Mars.
Finally, just before the auction, The still mystified Russians told Sotheby's they could sell the second robotic lunar rover the Soviets sent to the moon. And yes, it was still up there.
$60,000 on the telephone.
I suppose this didn't just mystify the Russians, it also mystified some of my colleagues here in our legal department. Really scratched their heads very hard about this one. I had to make a long announcement about how we would not make any representations or warranties about the future of space salvage law, all sorts of things like this. And there were questions about whether you charge sales tax, and I mean, there are lots of really bizarre questions they were trying to deal with. This did mean something. It really was a significant issue. To be the first person to own something on another heavenly body, I mean, that was a big deal. It gave you bragging rights, at least, to say, I bid on something that was on another planet.
The lunar rover ultimately went to an American for $68,500. Even before Pathfinder's spectacular mission, researchers had shifted their attention to the rusty world of Mars. Astronaut Shannon Lucid spent half a year in orbit on the Russian space station Mir, but she's ready for a longer trip.
The one thing that I would really like to do would be to go to Mars. I've been in space for 6 months, and especially from a personal standpoint, I know that it's not particularly a problem. And I've always had a real fascination with the planet Mars, just like so many people here on Earth.
Traveling from Earth to any locale beyond the moon will involve a major expedition. The distances are overwhelming. To get a handle on the scale of the solar system, once again we turn to Wayne Lee.
In our miniature model of the solar system, the Earth has been shrunk to a half-inch marble. I'm going to place the Earth at the starting line of the track. Now, the moon is a smaller marble about a foot away from the Earth. Now I'm going to jog to Mars. Now I'm here at Mars, 100 yards away from the Earth on our miniature scale of the solar system. If I wanted to get to Pluto, I'd have to run 15 more times around the track. If I wanted to get to our nearest star, Proxima Centauri, I'd have to run all the way around the world once.
If Earth were the size of a marble, Mars would be a 100-yard dash. But on the real-life scale of the solar system, a round-trip excursion to Mars would take at least 2 years. And it would be very expensive.
I don't think we're going to Mars in the next 50 years. I just don't see any point in having a huge expenditure of public money on just a prestige trip to take a couple of people to Mars and bring them back, which is all you could do with the present technology. I don't think it makes any sense. And I'm sorry for the astronauts, because that's what they'd love to do.
Technology is evolving fast, and in 20 or 30 years' time, it will be much easier to send people to Mars. We'll have better technology. People often look back nostalgically and say that the 1960s was the golden age of space exploration. And I can say that's totally wrong. The golden age of space exploration is way in the future. We're in the very primitive first stages of space exploration. And we'll do Mars, and we will do Europa, and we'll be all over the solar system. It may take 1,000 years, but there's plenty of time in the future.
What we'll have to master is a game of interplanetary pool, a mission of gravity.
In order to travel between the planets, you have to first escape the pull of the Earth's gravity. Once you do that, Newton's first law, if you apply that, you might think you could just point your rocket at the planet, fire your engines, and then coast to the other planet. In reality, that doesn't work because the pull of the sun's gravity will tend to pull you off course. So we have to take into account the fact that all the planets are in orbit around the sun, and what we do at NASA, in order to launch a spacecraft to another planet, we put it in an orbit around the sun that intercepts the planet that we're trying to visit.
Another method involves getting a velocity boost by first heading in the wrong direction and using gravity as a slingshot. The future in space depends upon cheaper access. It costs over $350 million every time the shuttle launches. But NASA has determined that it could cut launch costs with a modern, fully reusable spacecraft.
The shuttle is the world's finest launch vehicle in 1997. The shuttle in 1997 is a quarter of a century old. The computer on the shuttle is not as powerful as your desktop. We are trying to invent a new machine that's never been built before. It's called a single-stage to orbit. It's just like an airplane. Everything it takes off with, it lands with. So you don't need different systems, and you don't need a lot of people.
From designs submitted by major aerospace companies, NASA chose Lockheed Martin's VentureStar project for further development.
VentureStar is our dream of the future. Weighs roughly something over 2 million pounds at liftoff. Will carry a payload which is about the same as what the space shuttle can carry.
If the VentureStar succeeds, it will eventually replace the shuttle for moving astronauts and equipment back and forth between Earth and the future International Space Station. That project will consume a significant portion of NASA's resources for piloted missions for the next decade.
I have ambiguous feelings about the International Space Station. I may be biased because, of course, in 2001 it was a nice rotating ring with artificial gravity, whereas the space station plan now is frankly an orbiting pile of junk, the look of it. We need a space station. We're going to have one eventually. Whether it's the right space station at the right time, the right price tag, I wouldn't care to get involved in that argument.
The International Space Station is happening, yet it remains controversial.
The project's been driven by politicians for political reasons, and it's so large and it's such an important source of jobs, and it's just a huge welfare program for the aerospace industry. And whether it's any use or not has never really been the question.
It's better to think about it like the freeway system, the interstate highways. When they built them, nobody had to justify that they were going to have this factory here and this retail distributor here and this car dealer over here. We didn't know what was going to happen, but we did know that if we had a way of communicating and transferring things, the economic engine would be turned on. Same thing's true in space.
The most interesting thing to me about the space station is not the space station itself. It's the fact that there's going to be a place in space that'll be a sort of downtown. I think the interesting thing is not the station, but the neighborhoods around the station. I would love, for example, to get the concession to be the greengrocer for the station and the community that builds up around it.
This is our first step to provide a facility that lets people do whatever the future holds. But you have to have faith.
After the astronauts set up their orbiting city, it will be time for the rest of us to boldly go where no tourist has gone before.
A tourist in space. I think I would, if given the opportunity. I really think that I would.
Yes, without a doubt. Yes, ma'am, I surely would.
No, I wouldn't. No, I wouldn't.
I'd love to go as far as I could. What I'd most like to do is meet somebody else out there. With 100 billion galaxies, there's got to be somebody else out there. A lot of others.
I'm so spaced out living in Washington, D.C., that I don't have ambition, not today anyway, to go elsewhere.
With all the regulations, I can see it being hampered for another 20 to 30 years.
The idea is extremely popular, and most people, that's the majority of the populations of the countries we've questioned, say that if possible they'd like to go to space. And a substantial group, maybe between a third and a half, say they'd spend about 3 months' salary.
Everyone, this is Robbie the robot. Nice to meet you. Robbie's going to fill you in on the schedule.
First, we'd like everyone to get settled into their rooms.
Shimizu, one of the biggest construction companies in Japan, has already imagined an orbiting hotel. George Jetson is Conrad Hilton.
Living in zero gravity is extremely enjoyable. So if you have a hotel where you've got picture windows, zero gravity bars, zero gravity discotheques, karaoke bars, I think that guests they won't want to go home.
Are you coming back?
You bet. There's nowhere on Earth that's as much fun as this place.
Me too. Maybe next time it'll be my honeymoon.
I might give them a couple of flights just to let them shake out the bugs, but so I wouldn't necessarily want to be on the maiden voyage. But I think it'd be pretty hard to keep me off after that.
I would love to have that perspective. I would love to be able to be out there and look back at the Earth and get a different sense of how I fit in to the universe.
Let's separate out dreams and plans from a tourism industry. There's only one thing that's holding back tourism: $10,000 a pound for reusable vehicles. When we're able to get the cost of space travel down to hundreds of dollars a pound, there will be a tourism industry. It's as simple as that.
While pursuing a $25,000 prize, Charles Lindbergh risked death by flying the Spirit of St. Louis across the Atlantic. The outcome was the birth of a multi-billion-dollar aviation industry, leading to airplane tickets cheap enough for tourists. Space tourists could eventually rocket into space in a ship designed for something called the X Prize. It's a $10 million prize for the first private spacecraft that carries 3 people 62 miles up, beyond the edge of space, twice within 2 weeks. In the same way that daring entrepreneurs eventually got average people into the sky, modern visionaries mean to get them into space, by trial and error.
We're talking about pushing the edge of human capability. We're talking about frontiers, and frontiers always come at a price. The X Prize is dangerous. We are pushing the edge of space. We're proving the paradigm that governments aren't the only ones who can launch people into space.
Who knows? The winner of the X Prize could be the pioneering spirit behind all kinds of new commercial uses of space.
Within 10 or 15 years, the way you're going to get to Tokyo, your first-class ticket, will be a suborbital flight, where in fact you rocket out of New York Airport and go to altitude, 100 kilometers, out of the atmosphere, and literally on a suborbital flight, re-enter over Japan and land. And that all takes 30 to 45 minutes.
We can very clearly see a time when, if something absolutely positively has to be on the other side of the planet in 45 minutes, like my letter or my package, we can do that. We can have ultra-rapid courier delivery.
You know, in the old days, you used to have packages marked with airmail. Well, you're going to have them be marked with space mail.
Long before space mail, there is already a brand new space business: Space Memorial Services. Right now, currently orbiting Earth, are 7 grams each of the cremated remains of counterculture icon Timothy Leary and of Star Trek creator Gene Roddenberry, among other space enthusiasts.
The idea's been there, and we just saw that there was a worldwide interest in the service, and now technology and economics have allowed us to do it so that people can afford it. In just talking with the people that have made the choice to go with Celestis, they'll walk outside and see a shooting star on a dark night and think, that's where my husband needs to be.
Some believe that Space Memorial Services represent just a glimmer of the potential business in space.
There are multi-billion or trillion-dollar industries out there. The things that we as humans find most precious, real estate, energy, materials, that's you know, in spades in space. A half-kilometer nickel-iron asteroid, and there are tons of them, megatons of them in space. One of those asteroids on today's nickel-iron or platinum group metal markets is worth on the order of $30 trillion. There is a phenomenal amount of wealth in space. You know, when I grew up, I always wanted to be an astronaut miner, and I hope I get a chance to do it.
Imagine this. You work for Acme Mining and Engineering in Colorado, and you've just received a letter stating that you and your family are being transferred to an asteroid. The first space colonies will probably be outgrowths of some space industry that requires on-site human management. But ultimately, people will create colonies off the planet Earth for the same reasons they have always pushed beyond boundaries.
We're explorers. So going back to the moon and going back to Mars to stay is finding those volunteers, those early settlers who want to go make their life there and take the risk. I know I'd go in a heartbeat. I know probably 100 or 1,000 of the people who would go with me would go on their own. I mean, it's now. It's in our lifetime that we're going to make that transition.
Because people need oxygen, water, and food, to name the basics, creating habitable environments in space is challenging and expensive. Why send people at all? Robots are more and more capable, and they're expendable. You don't have to be concerned with bringing them back home at the end of the mission.
We know that machines tolerate accelerations and general conditions that humans would die instantly in those conditions. So you can say, well, logically, the future of space belongs to machines, except I don't believe that. I believe that humans will be in space for the best possible reason, which is we want to go there.
There's a place for both robotic explorers and for human explorers. And I think throughout you know, the history of space exploration, we've had the robotic explorers, but it's the human exploration that really captures the imagination, and it really captures the soul of exploration and the soul of the human being.
The robotic spacecraft really are extensions of our senses. They're our eyes and ears. They're the way we can currently explore places we cannot go.
In fact, Voyager 1, a robotic spacecraft launched 20 years ago, is now heading out of the solar system towards the stars. Because Voyager 1 would be the first envoy of man ever to venture beyond our tiny section of the universe, the late Carl Sagan headed up a cross-disciplinary team to determine exactly what messages from Earth should be sent along. Ultimately, the spacecraft was launched carrying a gold-coated record containing 118 photographs and a large selection of music and sounds of Earth, including greetings in 55 different languages.
पृथ्वी ऊपर बसनार एक मानव तरफ थी ब्रह्मांडना अन्य अवकाशमा बसनाराओने.
That's Gujarati for greetings from a human being of the Earth. Please contact.
I think it was our sending which was the most important symbol, rather than the idea that anything would ever actually receive the message. It was the fact that we as a civilization had reached the threshold of being able to send such a message.
Nevertheless, effort went into deciding what messages from Earth should be sent with Voyager 1, because the possibility of the messages being received by something or someone captivated so many people.
As you lay out on the fields and look at the dark sky and look at all the stars, and you see all these thousands and thousands and thousands of stars, and you think of the possibility of other solar systems, it's just very difficult to conceive that we are the only intelligent beings in this vast universe.
For me, if we could find a single cell of life that lives off rock and water, it would say that we have an understanding that life is not unique to this planet. I would be satisfied with a single living cell. Beyond that, it would be only gravy.
We may find life on Mars if we're lucky, But intelligent life, we probably have to go interstellar distances, maybe long interstellar distances, maybe thousands of light years, to find the friends and neighbors that we would so much love to converse with.
Gee, Commander, these Martian totem heads sure are spooky-looking things, aren't they?
The ancient race of Conicus didn't think so. You'll see lots of them in that Conican city we're going to visit. The totem heads are supposed to guard their cities.
I think human beings have a tendency to fear that which we do not know. We do have a tendency to, when portraying life from other parts of the galaxy, oftentimes it is a very menacing presence that comes to visit.
Alien intelligence, it's not scary to me, but then I haven't been really confronted with it, so now it's just fun to talk about. But if some alien guy walked in and he grabbed me by the throat and took me up to his space, I'd say, now I'm scared.
Space holds such a fascination for us because of what it represents to us, because of what it's come to represent, you know? That vastness being the unknown.
That vastness, the mind-boggling distance from Earth to even the nearest star, puts a crimp in turning human star travel fantasies into reality anytime soon. The chief problem, there's a speed limit.
In the laws of physics, the speed of light is the fundamental speed limit. That's about 186,000 miles per second. And that's what really limits us in terms of being able to travel to the stars. If you wanted to go to the nearest star, Proxima Centauri, that's 4.3 light years away, which means you'd have to be going at the speed of light for over 4 years just to get there.
The thing about interstellar travel, of course, is that it's enormously bigger enterprise than tootling around the solar system.
I am sure that we will conquer light speed. Now, I may not see it in my lifetime, but some scientists or some physicists somewhere along the line will develop the techniques and the machinery to conquer light speed. I think interstellar travel is going to be fantastic. It's going to be fascinating. And that's when we're going to start meeting some of the other beings that are in the universe.
Whether or not we ever crack the barrier of the speed of light, most agree that someday humans will find a way to travel among the stars.
You stand here and you know, you give that signal and you just kind of particulate and appear somewhere else.
Beam me up, Scotty, and then you're gone. That's all I know about it.
Well, in Star Trek, they sort of break you down into atoms and just take you apart, really, and then they can transfer your body into a radio signal and they can beam you to different spots. And Scotty is the technician, you know. He's, you know, the most famous. Everybody loves Scotty. And beam me up, and he's the one who always beams you up, so everybody else beam me up Scotty whenever they want to go somewhere.
Science fiction, to me, has always tended to pose two of the most powerful words in the English language. What if? What if? And by asking ourselves that question, we have demonstrated time and time again the remarkable ability to go on and answer that question in some really clever, phenomenally clever ways.
Some credible theories for interstellar travel originated as science fiction solutions for getting around the light speed limit. You have to plan for a journey that would take at least 30,000 years at today's fastest speed.
We could launch a self-contained, a biodome, okay, into space, which would be completely self-renewing with plants and animals and everything else. I don't know how big it would have to be. And we could launch that quite slowly off to the stars. Assuming it's a multi-generation ship so that people live just as we do here on Earth, and that they survive and that they don't run out of some vital components or run into a rock or something like this. Eventually, and the eventually is the big point, they'd get to the stars.
While this kind of multi-generation spaceship is theoretically possible, a biodome experiment here on Earth didn't work very well. Crops critical for producing air and food died, and the volunteers got on each other's nerves.
And going into suspended animation, I would think, is a more practical way. Just go into the deep freeze for 500 years, and so then you come out bright and cheerful when they come to the end, and saves a lot of this intermediate boredom.
In Hollywood, deep freezing bodies for lengthy interstellar trips has been a popular method for space travel. But it never seems to go right.
Alpha Control's final analysis of the Gemini 12's flight indicates, unhappily, that the spaceship has either been destroyed or must be presumed lost in space.
There's danger, Will Robinson. For the moment, star travel is purely theoretical, except by telescope. And NASA's extraordinary New Origins telescope project is going to take Earthlings on a very strange trip. The Origins telescope will be able to spot planets orbiting distant stars, about as difficult as seeing a firefly next to a searchlight in Moscow, from New York. By analyzing the light, astronomers will determine which planets have atmospheres that could support life.
We would like to place this Planet Finder telescope out around, say, in the orbit around near Jupiter, because near the sun there's a lot of dust in our solar system which scatters sunlight, and that would be a background which would make it difficult to see, for us to see very faint light coming from other solar systems. I think our exploration of other solar systems and our search for life elsewhere will, for many, many decades, really involve this remote observations with increasingly sophisticated observation systems, because it is so difficult. In fact, we don't know how to get there. Of course, ultimately, as we've learned with our own solar system, you really do learn a great deal more by going there.
People thought we'd never fly, and of course we flew. People thought we'd never fly faster than sound. Of course we fly faster than sound every day. People thought we'd never travel into space. We travel into space.
And now robotic spacecraft are on their way out of the solar system. Who knows what's in store?
I believe in 20 to 25 years, we will have permanent base on the moon. In 20 to 25 years, I believe we will have already been to Mars, and the first human footprint will have been on Mars. We might have a research station on an asteroid with people. And I think in 50 years, space travel will be much more routine. I think that a hotel and a Pan Am shuttle or whatever company might do it is not out of the question.
In 500 years, we will be all over the solar system. Humans and their attendant machines will be exploring and active and have bases everywhere through the solar system.
A few things we know. Our future in space is certain. The space age is in its infancy, and each generation will push the edge. There are no final frontiers.
When our children can't dream and believe their dreams are going to come true, I'm not sure we have a society that's worthwhile. And for me, I'm a rocket scientist. Space is my vehicle.
2, 1.
still being studied. So why do so many people want to go?
This whole idea of how somehow, through our exploration of what's out there, we could come in contact with our relationship to the divine is, I think, a big part of why we do this.
I think one of the real reasons for exploring space is to see if we're alone in the universe or whether there are other life forms out there. It's hard to think of a more important question from the point of view of philosophy, religion, sheer curiosity.
That's one of the main driving forces of my interest. I want to find the aliens too.
You've got company. All right.
Whether searching for aliens or even God, a basic reason for exploring space is simply because it's there.
We're fascinated by pretty much any open frontier. Think of the effort that went in the first part of this century in getting to the poles.
I just think it'd be just fun to go to another planet.
Set up like cities out in space.
I think I want to go on an Apollo mission so I can do a spacewalk.
Since the early 1960s, when the possibility of human space travel became reality, kids, and adventurers of all ages, have dreamed of going into space themselves.
Sometime in the 21st century, your children's children may very well fly Pan Am to the moon.
In 1968, Pan Am kicked off a curious ad campaign. They were accepting reservations to guarantee seats on their future flights to the moon. 93,000 people made reservations.
I was one of the first 100 to make a reservation for the moon flight. I was working at the William Morris Agency at the time, and a very excited Albert Brooks, who was one of our clients at William Morris, came running into my office and saying that he just heard that Pan American Airways is taking reservations to the moon.
They were taking reservations if you wanted to go to the moon. They were eventually going to have a ship that would go there. I sent away for tickets for me and my future wife. I didn't even think about maybe I'd have kids.
Affairs are not fully resolved and may be out of this world. We ask you to be patient. Is 28 years enough time to be patient?
There is no environment more alien to the human body than the emptiness of space, where temperatures can fluctuate 500 degrees, where, without the protection of a spaceship or a spacesuit, the vacuum would make blood boil. It takes the most sophisticated machines ever built to get into space, and the effects of long-term space travel on the human body are...
Why did we keep trying to get to the top of Everest? It was simply a frontier that we hadn't been to, and space is the same thing, which is why I think we have a long future in going to space.
Humans are natural nomads, and we've always somehow been restless and moved around from one place to another for reasons we don't know. I assume that'll continue to be true. So there are lots of reasons why people might like to go. The simplest is just to get away from their neighbors, and that's, I think, a fundamental instinct in many of us.
Another good reason for exploring space has only just been discovered. We realize now that the Earth is continually bombarded by asteroids, comets. It doesn't happen very often, but when it does happen, the effect can be devastating. Meanwhile, it would be a pretty good idea to establish a few other colonies on the Moon and Mars and elsewhere, so that even if there's a major catastrophe to the planet Earth, some part of the human race will survive.
6, 5, 4, 3, 2, 1, 0.
The American obsession with space began in 1957 with the news that the Soviet Union, the United States' Cold War foe, had successfully launched a satellite into orbit. The space race was on.
At an altitude of 560 miles, at an estimated speed of 18,000 miles an hour, the first man-made satellite is orbiting through the heavens, sent there yesterday by Soviet Russia.
In 1961, the Soviets stunned the world again when they launched the first human being into space. About his trailblazing single orbit of the Earth, cosmonaut Yuri Gagarin said, "I looked and looked and looked, but I didn't see God." The Soviets may not have found God. They did find glory.